Domantas, the floor now is yours. Domantas, you might be muted, so please check your microphone settings.
Hello, everybody. My name is.
We can hear you now.
Domantas. You can hear me? Okay, sorry. So I have here the robot inserted the pieces into the feeder, and now I will prepare. I will talk about the RoboBend and how it's working. So Thomas presented it in a brief way, so I will try to explain it in a bit more detailed way. So let me start from introducing myself. So I'm Domantas, and I'm the chief engineer in RoboBend. And we have developed this solution to help metal industry companies with automating press brakes. So as you can see, the robot has already started doing what human operator would normally do. It started picking up the pieces from a stack, then aligning them and putting them into the press brake. So the RoboBend is actually just in the place of a human worker, but this lets the humans to do some other work which requires a bit more like creativity, and lets them, for example, operate a couple of RoboBends. So in practice, one worker could operate 3 or 4 RoboBends, which would increase the output of the whole company. And it helps to save time too, as the robot can work without any human interference. So how the whole system works is that there is a feeder from where all the parts are placed, and it works similarly to a printer where you put a stack of pieces, and the robot picks them one by one. And then the feeder has additional sensors and equipment such as separator, so to ensure that the robot is picking up only one piece at a time, to save some time and to ensure quality of the bend. So then there is the main cell. On the main cell, we are using the FANUC LRMate 200ID7L arm. This arm has a 7 kilogram payload. So in theory, you could work with pieces which are up to 5 kilograms because the gripper adds some weight. The maximum dimensions which are allowed for this version of RoboBend are 700 millimeters by 500 millimeters. So basically, you can take a sheet which is as big as the feeder plate and lift it with the robot. So then on the main cell we have also an aligner, which is responsible for calibrating the pieces taken from the feeder, because there might be some position errors. So we are using a gravity operated aligner to ensure that the piece is positioned and calibrated for the bending procedures. So from the aligner, the robot moves straight to the press brake. In the press brake, the robot is inserting the pieces at pre-programmed positions and repicking them after the bend is complete. If there is a need to reposition Also on the main cell there are 2 points called overturners, which are used to change the gripping positions, because most of the pieces require some kind of regripping to be done in middle of the bending sequence. So we have 2 of regripping points. One is mechanical one, and the other one is packing. So these are the main components of the whole cell, main cell, and the last physical part from the RoboBend is collector. So collector has a big full-sized Euro pallet put on top of it, where the parts can be stacked nicely and taken out with a pallet truck, or simply just by going in there and taking them by hand. There is also an opportunity to choose different palletizing options, such as dropping into the box. So this method is more useful when working with smaller pieces and when batch quantities are very big. So you can basically take a piece and drop it into the box. So when you reach full capacity of the pallet, the robot stops and notifies the operator, for example, using email that the pallet is full and you should come and change it so the robot can continue working. Also, the operator is notified when the feeder is empty and when there are no pieces left. So then also there's a sound coming, and then the operator is also notified using email that some attention is needed. So then the operator can know when to come and is fully free to do something else until he gets some notification from the robot. So these are the main physical parts of the RoboBend, but of course there is some electronic side and programming side. So the biggest electronic side for the RoboBend is RBMI, or Robot Bending Machine Interface. So this interface is used to communicate between the robots and the press brake. So using this system, we can simulate the work of the human operator, and instead of human operator looking at the press brake and understanding in what state it is, top and bottom or bending, so we are using the bending machine's logic and inputs to determine in which state the machine is, and then we are using the controls of the press brake to control it to start braking, to start bending, or hold the position nicely gripped in between, so the robot could move to a picking point. So this interface is available for most of the machines. Also, some functionalities are depending on the press brake's controller and if it has a lot of features or not. So we're basically suggesting for some companies to increase their effectiveness to upgrade to maybe a newer controller, which will anyways add new functionalities to the old controller, and it will like have a nice looking 3D interface and everything like that. And then it would be easier even to use with the RoboBend, because there would be added functionalities. But as you can see, this press brake that we're using now, it doesn't have a lot of like additional features. It just has a package, which is just one axis, and everything is still compatible with the robot, and it's working very nicely. And because of this, we can say that we can connect to most of the old press brakes, and if we cannot do that, so we have the option to install newer controller, and it will add all of the features that we are looking for, and it will add some of the features that you can use manually on your press brake. So this is the main functionality of the ABMI, and the other thing which is very important for the operation of the RoboBend is user interface. So user interface is made for two operators. So one operator is like manager, ship manager or a company manager, who is responsible for creating new parts, inserting all of the information about the part, and then making orders for manufacturing. So you can put all of the information start of the manufacturing and how many pieces there should be made. And when all of this information is created, the operator can see it in his own user interface and see what kind of orders are planned for today, for tomorrow, or at any date. And then he can prepare for those orders also, because there is information given what kind of position the pieces are gonna be stacked in, what kind of gripper there has to be, because we have a few different grippers. So for bigger parts, there should be installed a bit bigger gripper, and all of this information is shown in the user interface. So it is easier for managers to see and to plan their production, and it is easier for operators just to keep working and make no mistakes, as all of the necessary information is given to the operator in separate user interface. So what other features are there in user interface? So we have all of the components which are saved and which are prepared for the bending. So when you would like to start to bend some pieces which were already set up, and you installed all the press brake tooling and checked the positions of the parts in the feeder, you can start this program and start manufacturing in a matter of a few minutes. So choosing between programs which are already set up is really fast and doesn't take a lot of time. So now we see that the robot has finished one batch of the parts, and as we prepare for the other one, we're just gonna take the pieces out of feeder and load up the new program. So in the meantime, I am going to tell you about the offline programming. So for offline programming, we are using Obelisk, and for Obelisk, we are for the Obelisk, we have the opportunity to set everything up offline. So all of the programming is done in a simulation program, and we can see all of the movements for the robot. So what kind of information would you need to create new programs for the RoboBend? So basically what you need is the XF file with the counter and bending line, and then the drawing, which includes information about what angles the bend should be, in which direction, and what are the dimensions of them. So then when you have this information, you're putting it into the Obelisk, and after adjusting gripping positions for the robot and checking if the movements for the robot are fast enough and they are efficient, you can generate the program. After generating the program, Obelisk allows you to see the simulation. During the simulation, you can see all of the movements of the robot and how it would be moving. So it helps to foresee some mistakes you might have done and to fix them while you didn't have to go to the robot and test them with the robot. After programming and making sure everything is okay, the generated programs can be sent to the robot, and you can run it a few test runs to see how everything is working. And after you have tested it on the robot, you can create a project with all of the information and prepare it for the manufacturing. So you will be ready to manufacture those pieces at any time in the future. So basically, these are all the major parts of how the RoboBend works. What is the other very important thing is safety. And to ensure safety, we are using organic glass, a kind of organic glass which is called polycarbonate, which is very hard and sturdy plastic. So it allows us to separate human operators or our people who are working around the robot to be safe around it. So the robot cannot exit any of the points from the cell, and the humans cannot interact with the robot when it's moving. So for the sake of better visibility, we left one door open so we can see this robot moving, but during normal operation it wouldn't be allowed, so humans couldn't open the door because then the robot would be stopping. Other safety features include emergency stops and compressed air sensors. So there's, for example, no compressed air, so the robot also gives out a signal that the air pressure is too low, and the operator is notified, and the robot is stopping the movement also. If there is anything wrong from the press brake side, side door is open or something like that, so then the press brake stops by itself because it has its own safety system, and the robot reacts to it too, as we connected both safety systems. So if we have some additional safety systems which are installed on the press brake, we're gonna be connecting to them too. So the robot can stop the press brake if there is any kind of emergency, or the press brake can stop the robot. So in this way, we are ensuring that operators are kept safe and there are no problems for them. And I think this covers all of the main parts for the robot and how it works. So just to repeat myself in a short notice, I can just remind how everything should be looking if you're using RoboBend. So, for example, everything starts for that you get some drawings with the parts and how they're going to be looking. So you have to have some DXF file with bending lines and contour for the pieces. And then you are putting this information into Obelisk. In the Obelisk, you are adjusting positions of the robot to get required movements from the robot and to ensure that there are no collisions and that you are efficient in the manufacturing plant. After you have generated the program, you, as a manager, for example, you are preparing the order, putting all of the necessary information, such as where the stack of pieces should be in the feeder, what kind of gripper should be used, what tooling should be installed on the press brake and where it should be positioned, and lastly, what kind of palletizing you are hoping from the RoboBend so the operator can prepare for such a palletizing. So from the manager's side, when all of these things are done, it is done. And the next steps are for the operator of the RoboBend to come and prepare the cell. So we have a modular cell, and the collector, main cell, and feeder are all separatable and easy to disconnect from each other. So if RoboBend is moved away, so the first thing would be to move the main cell to the near the press brake and couple it to the ground. After doing that, you can attach the collector and feeder. After doing these things, you insert a pallet with a feeder plate on which all of the pieces are stacked in a nice fashion and according to the information the manager has prepared. After that, you should make sure that you have installed the right tooling on a press brake, and after checking all of the information, you can just start the program and everything is ready to manufacture, and operator can move to prepare for a new piece maybe, or to work on our machinery. So, and the robot can move until the stack is, as I said, is empty, or until the collector is full of pieces. Last thing to mention, I think, is the feeder height. Maximum size is like 800 millimeters. So if you're using a 1 millimeter thickness parts, that means that you have like around 800 of them can be stacked in one go for robot. So if you take account that one part is like 1 minute to bend, so in theory that would be taking the whole shift for the human operator. So that means that human operator, for example, comes to the RoboBend in the morning, puts the pieces into it, and then for the rest of the day, the robot is bending, and the operator doesn't have to do anything except from time to time to just change pallets so the pieces would have a place to like be palletized for. So at the end of the shift, the operator can also come and put some parts into the RoboBend and let it work after the human operator shift has been over. So you can actually get the notifications to the email while the robot is working, and if there's gonna be any issues, you will be notified. And also we have an internet camera installed on the RoboBend, so you can connect to it and see how everything is working. So you can do it remotely from the office or any other place, just to make sure that if it's running, you can be sure that everything is okay. Or if you have had some notification, you can just check what kind of problem there is in the RoboBend. So I think this is all of the main parts for the robot and how it is